Hello everybody, this is Gary Merzinski and welcome to Chapter 6 of The Microeconomy Today by Schiller and Gebhardt. This is the second chapter in a row that deals with consumer behavior, trying to understand, this is the demand side of a market, how individual buyers make their purchase decisions. Price elasticity is part of the explanation for consumer behavior for any given product. And we're going to spend most of this chapter talking about price elasticity of demand, but then we'll also touch on price elasticity of supply. And price elasticity, remember, the law of demand tells us that as the price goes up, quantity demanded goes down. As the price goes down, quantity demanded by buyers goes up. Elasticity answers the question, how much does quantity demanded go up when the price goes down? How responsive are buyers to a change in the price? Elasticity is a measurement of how responsive buyers are to either an increase or a decrease in the price. Please ignore that dog barking in the background. That is my beagle, Luna, and I'm hoping she'll behave today. But we'll see how it goes. So let's start with this scenario. You have a business and you design websites for small businesses, and you charge $200 per website. So these are simple websites, I would assume, if you're only charging $200. Currently, you're selling 12 websites per month. You're considering raising your price to $250 per website. The law of demand says that you're going to sell fewer websites. Again, elasticity will help you to understand how many fewer will you sell. What happens to total revenue when you raise your price to $250? Well, you're getting more per website, so that should make total revenue go up, right? Wait a minute, not necessarily. Total revenue equals price times quantity sold, right? The price you're charging times the quantity that you're selling. Price times quantity. If you raise the price, well, that will have the effect of making total revenue go up, except for the fact that the quantity demanded is going to go down. So it depends on how much the quantity demanded goes down relative to the price increase that answers the question whether your total revenue will go up or go down. This is the importance of price elasticity of demand. Again, the law of demand tells us that if the price is increased, the quantity demanded by buyers goes down. But how much does the quantity demanded by buyers go down? The price elasticity of demand is a measurement of that responsiveness of buyers to a price change. In general, elasticity is the responsiveness of one variable to a change in another. In this case, the two variables are the price of the product and the quantity demanded by buyers. And what I just explained is depicted on this slide. Elasticity is measuring the responsiveness of one variable to a change in another variable, assuming that they are correlated. And the variables we're interested in here are price and quantity demanded. We'll also look at quantity supplied later on in this chapter. Here's an equation for price elasticity of demand. The percent change in quantity divided by the percent change in price. So the price changes, which prompts a change in quantity. Remember that quantity always goes in the numerator. The price change goes in the denominator. Okay? Now, the way I like to think of this, I've never seen this explained this way by anyone else or in any textbooks, but the way I like to think of it is the demand for a product is elastic if buyers overreact to a price change, such as a price increase. It's inelastic if buyers underreact to a price change, such as a price increase. So let me give you an example. Suppose that the price of the product goes up by 10%. You would expect that an appropriate response on the part of buyers would be for the quantity demanded to go down by 10%. But if the price goes up by 10% and the quantity demanded goes down by 20%, you would say that buyers overreacted to that price increase. If that's the case for a product, that product has elastic demand. The price elasticity of demand for that product is elastic. On the other hand, if you raise the price of the product by 10% and buyers react by decreasing their quantity demanded by, say, 2%, then they underreacted to that price change. If that's the case, then that's a product that has inelastic demand. Here's an example looking at the demand curve of a price change that causes a quantity demanded change. So there's your demand curve. Let's say we start at point P1Q1, and we don't have numbers here, but we're given the information that the price is increased by 10%. So it goes from P1 to P2, that's a 10% increase. That leads to a 15% decrease in the quantity demanded. Plug those values into our equation at the top of the slide. Remember, the change in the quantity always goes in the numerator. So then that's 15% divided by 10%, which gives you 1.5. Remember I told you if buyers overreact to the price change, that's elastic demand. If buyers are overreacting, that means the percent change in Q must be greater than the percent change in P. If that's the case, given our equation, then we'll always end up with a price elasticity greater than 1. And in fact, that is the case. That is the definition of elastic demand. If the price elasticity of demand is greater than 1, then you say that it is a product that has elastic demand. And of course, the more greater than 1 it is, the more elastic it is. The closer to 1 it is, then if it's just a little bit over 1, then you might say it's slightly elastic. If it's under 1, it's inelastic demand. And the way you see the equation at the top now in mathematical notation, delta represents change. It's a mathematical symbol that represents change in a variable. So that would be percent change in Q, quantity, divided by percent change in P. That's how we're going to do this. Now, if the price change is a positive change, that would be an increase in the price, then the percent change in quantities is going to be a negative number, right? A negative percentage. That will be the case because these are variables that move in opposite directions, right? If the price change is a negative price change, you're dropping the price, then the quantity change is positive. So there's always going to be a negative either in the numerator or the denominator when we're computing price elasticity of demand, which means you'll always end up with a negative number. We're just going to ignore that and just to simplify things and just understand that the price elasticity of demand is always going to be a negative number. So here's an example with some numbers. This might be our website business scenario that was on the second slide. And in this case, it looks like we're raising our price from $200 to $250. And then the quantity demanded goes from 12 per month to 8 per month. Remember, when you're computing the percent change in a number over time, it's always the new value minus the old value divided by the old value. That's the way you always do it. So for example, if my income goes from $50,000 a year to $52,000 a year, what percent change is that? It's the new income minus the old income divided by the old income. So 52,000 minus 50,000 divided by 50,000. So that's 2,000 over 50,000, which is 4%. Always remember that the old number goes in the denominator. The old number is the base. That's the important thing. So if we were to do this the same way, this complicates things for us. Because if we go, for example, we're going from point A to point B. What's the percent change in quantity? Well, it looks like we went from 12 to 8. Looks like we decreased by 1/3, right? 4/12. That's a 33% decrease. Okay, what if we went from point B to point A? What's the percent change in Q? That's a 50% increase. So it's different, right? Because you have a different base now. And there's a similar issue with price. If the price is increased from $200 to $250, that is a 25% increase. If you decrease from $250 to $200, that's a 20% decrease, right? This is a complicating factor. The fact that going from point A to point B gives you a different price elasticity than going from B to A. We would like for it to be the same. So we're going to modify our equation just a little bit. This is explaining what I just talked you through. When you go from point A to point B, it's a different percent change in price and in quantity than if you go from B to A. We would like for the percent changes to be the same regarding price elasticity. The way we will deal with that in this chapter with price elasticity of demand, when there's a percent change, we're going to use what's called the midpoint formula. In the denominator, instead of using the old number, the starting value, we're going to use the midpoint between the two numbers. So new number minus old number divided by their midpoint. Their midpoint would be their average. And I'll give you an example to show you how this works. Then it's the same no matter which direction you're going. So looking back on our graph from 2 slides ago, if the quantity demanded changes from 12 to 8, using the midpoint formula, in the numerator, it's the difference between the two numbers, 12 minus 8, divided by their midpoint. Their midpoint is just their average. Now, in a lot of cases, you can, by observation, decide what the midpoint is. The midpoint between 8 and 12 is 10. But in more complicated cases, it might not be so obvious. Just add them together and divide by 2. That is their midpoint. Their average is their midpoint. So then you have 4 over 10. That's a 40% change. So in other words, it's a 40% change when you go from a quantity demanded of 12 to 8, and it's also a 40% change when you go from a quantity demanded of 8 to 12. It's just, in one direction it's a minus 40%, in the other direction it's a plus 40%. But it's going to be 40%. The same thing applies to price. If the price changes, in this case the old price would have been 200, goes from 200 to 250, the new number minus the old number in the numerator divided by their midpoint. What's the midpoint of 200 and 250? 225. Again, in more complicated cases, just average the two numbers together. That gives you their midpoint. That's the denominator. So then you end up with 50 divided by 225. That's a 22.2% change. It's 22.2% change if you go from 250 to 200, and from 200 to 250. If you're using the midpoint formula, that's the whole point. So that's how we're going to compute the percent changes in computing price elasticity of demand. Okay, let's see if you can compute this one. Use the price elasticity of demand equation and come up with price elasticity of demand using these values. All right, the price changes from $70 to $90. That makes the quantity demanded go from 5,000 to 3,000. Figure out the percent change in quantity using the midpoint formula. That's in the numerator. Then figure out the percent change in price using the midpoint formula. That goes in the denominator. So pause the video right now, get a piece of paper out, and see if you can compute price elasticity of demand. So here's the problem solved for you in red. The price went from $70 to $90, which made the quantity demanded change from 5,000 to 3,000. And these are actually shown backwards, but the direction doesn't matter because we're using the midpoint formula, right? So the difference in quantity demanded is 5,000 minus 3,000. Divide that by the midpoint of 5,000 and 3,000. That's 4,000. That's a 50% change using the midpoint formula in quantity. That goes in the numerator. How about price? The price changed from 70 to 90. So the new price is 90, the old price is 70. The difference between the two is 20. So it's 20 divided by the midpoint of 90 and 70, which of course is 80. 20 divided by 80 is 25%. Now plug those into the price elasticity of demand equation. You have 50% divided by 25%, which gives you 2. So is that elastic demand or inelastic demand? Remember how we decide. If price elasticity of demand is a number larger than 1, it's elastic demand. Buyers have overreacted because the reaction of buyers is in the numerator. The price change is in the denominator. So if the quantity change is greater than the price change, that's an overreaction. You'll have a numerator larger than your denominator. That always gives you a number greater than 1. In this case, it's 2. So this would be very elastic demand for whatever this product is. So what determines whether a product has elastic demand or inelastic demand? What characteristics of the product? There are several possible characteristics of a product that could sort of bear on whether buyers overreact to price changes or underreact to price changes. Let me give you a simple example and try to think this through with me. Which of these two products would you say would have the more elastic demand? The more elastic demand. Buyers would be more responsive to the price change. Breakfast cereal or sunscreen? Breakfast cereal or sunscreen? Just think about how you would react to, let's say if the price were to double. If the price of breakfast cereal were to double, would you react in a bigger way than if the price of sunscreen were to double? What is it about these two products that's different, which would make them have different elasticities? Well, suppose the price of cereal were to double. What would you do? You would probably buy some other type of breakfast food, wouldn't you? You would start buying oatmeal or English muffins or something else other than breakfast cereal. You would find some substitute, wouldn't you? What if the price of sunscreen were to double? Well, there is no substitute, right? If you're in the market as a buyer of sunscreen, there really is no other product to substitute for sunscreen, is there? You need the sunscreen. So a characteristic of a product that could make it more or less elastic is, are there close substitutes available? If there are close substitutes available, the elasticity will be higher. If there are not close substitutes available, like with sunscreen, the price elasticity will be lower, or it will have inelastic demand even. All right, let me give you another example. Which of these two products would have the greater elasticity? Buyers would react in a bigger way to a price change. Blue jeans or clothing? And just think about, again, think of a doubling of the price. I like to think of big changes when I'm trying to understand the effects of a price change. Imagine it's a big change in the price, like it actually doubles. How would you react if the price of blue jeans doubled? How would you react if the price of clothing doubled? Which one would get the bigger response out of you in terms of decreasing your quantity demanded of that product? Well, if the price of blue jeans doubled, you would probably buy some other type of pants, right? But if the price of clothing doubled, you've got to buy clothing. So you can't be as responsive, right? So the issue here is how narrowly defined your product is or how broadly defined your product is. How narrowly defined is the market or how broadly defined is the market? The more narrowly defined the product category is, then the more other options you would have to go to, right? Clothing is a very broadly defined product, and there's nowhere to go. Blue jeans is a subset of clothing, right? So again, the more narrowly defined the product is, the higher the elasticity will be because you can jump to some other product. It's very close to the substitute issue, right? There are other substitutes. If the price of blue jeans were to double, you would buy khakis or shorts or something else. But if the price of clothing were to double, there's no real other substitute for that. So that's going to have a lower elasticity. It would be actually inelastic. Here's another example. Which of these two products would have the bigger elasticity? Chewing gum or automobiles? Chewing gum or automobiles? How would you react if the price of a pack of chewing gum were to double? Would you react in a bigger way than if the price of automobiles were to double? Well, this one's pretty obvious, right? You would react bigger to a price change in automobiles. Think of a decrease in the price, too. Suppose there were a 50% decrease in chewing gum prices. Would you buy? How much more would you buy? Or a 50% decrease in automobiles, new automobiles. You would act in a bigger way to a price change in automobiles, because automobiles have a much larger price. The price is much greater compared to your income than chewing gum. That's an inexpensive product, so you're not going to be as price sensitive when the price of chewing gum changes. Automobiles, you're going to be very price sensitive because that's such a big expenditure for you. So that is another characteristic of a product that could make it have elastic or inelastic demand. All right, here's another example. Which of these two would buyers have a bigger reaction to when the price changes? Which of these two would have the larger price elasticity? Insulin or Caribbean cruises? Insulin or Caribbean cruises? If the price of insulin were to double, if the price of Caribbean cruises were to double, which of the two would get a bigger reaction out of buyers? And these are opposite products in some way, right? What's the way? Insulin is a necessity. If someone is a buyer of insulin, then for them, it is an absolute necessity. You need it to live. Now, the law of demand still does apply. If the price of insulin were to go up, quantity demanded will go down. Some buyers of insulin will find some way to economize and not use as much, maybe skip a dosage every so many days or something, but they're going to buy just about the same amount, just a little bit, tiny bit less. But the percent change in quantity demanded for insulin is going to be much smaller than the percent change in the price. On the other hand, Caribbean cruises, that's a luxury item, right? If the price of Caribbean cruises were to double, or imagine that it goes down by 50%, people are going to buy lots more Caribbean cruises because it's a luxury. If the price were to double, they might stop buying them altogether. So a much bigger response in the quantity demanded when the price of a luxury item changes, because it's not something you really need. So this is a characteristic of a product that could determine whether it has elastic demand or inelastic demand. Is it more of a necessity, like gasoline, or is it more of a luxury, like jewelry, travel and tourism, and so on? Now, another characteristic of a product that could determine whether it has elastic demand or inelastic demand. I like to tell a story, a personal story. This is a true story that sort of gets at this point. I got my first full-time teaching job. I transitioned out of industry, so I started my career as an engineer. I was working in manufacturing for 11 years. Then I went to healthcare, an engineering position in healthcare, working at a medical center for 7 years. So it was 18 years into my career, but I was teaching at night in a business program at a local college. And I wanted to transition full-time to teaching. And so I accepted a position at a pay cut to teach. I live in this area, which is northeastern Pennsylvania. This was a college in New York, and it was a 60-mile commute for me, one way. So 60 miles each way. All right, so I figured out what the cost of transportation was going to be and sort of justified, this is in 2004, and tried to figure out what my costs were going to be for that, to travel every day like that. And yes, I really do want to transition my career at this point in my life, and so I was willing to live with that, and so I did that. All right, so I'm teaching now full-time in New York, and over the course of the next year and a half, prices go from under $2 a gallon to $4 a gallon. Pretty close to what they are now today, and this is all those years ago. All right, So that's a price increase. That's a doubling of the price of a gallon of gas. My quantity demand is going to go down some, right? How much does it go down? How do I decrease my quantity demanded? Does my demand for gasoline, is it inelastic or is it elastic? Or it's going to be inelastic. How inelastic is it? In the short run, what could I do as the price went up to decrease my quantity demanded? Not that many things, right? I mean, I could try to not drive as much on the weekend and try to not drive as much other than going to work. That would decrease my quantity demanded because the price went up so much. If I had a little more time, I could sell my car. I was actually driving a Hyundai Santa Fe, an SUV, which I thought would be useful because of the winter driving through the northern tier of Pennsylvania. This is in upstate New York where I was working. A lot of snow. Well, that is a car that does not get very good gas mileage. So if I have another couple months to react, or a couple weeks maybe, I could trade in my car because I've got to research where cars are, how much it's worth and how much I want to pay and everything, and buy a new car. If I have a little bit of time, I could buy a more fuel efficient car and my response would be greater. What else could I do? Well, there's two other things I could do, right? And I actually did look for carpools. There was no one else traveling from where I lived to that college, so carpooling was not an option. I could sell my home and move there, right? Move to New York. Now, that's not something I could do in the next week. I've got to put my house on the market. I've got to locate a house I like. So I've got to sell one house, buy another house, or at least find a place to rent. So if I have another 6 months to react, I can be more elastic in my response. What's another thing I can do? I can find a job that's closer to home. That might take even longer. The whole point is, imagine that the price changed in one day and it doubled from $2 to $4 a gallon. In the short run, I have very inelastic demand for gasoline. There's not that many things I can do in the next couple days to decrease my quantity demanded. I still have to drive 60 miles, really 120 miles round trip. But given more time, I can make other adjustments to my life to allow me to decrease my quantity demanded for gasoline. So the lesson is, the longer the time frame is, the longer the period of time I have to react, the more elastic my demand will be, or the more inelastic it would be for gasoline in this case. The shorter the time horizon, the more inelastic my demand is. So, another way to word this is price elasticity is higher in the long run than it is in the short run. Here's a summary of these different characteristics of products, determinants of price elasticity of demand. Are there substitutes? Are there close substitutes available for the product? If there are, the demand will be more elastic. People will respond in a bigger way to a price change. How large is the price of the product in proportion to a buyer's income? The larger the price, the greater the price elasticity of demand. Is the product a luxury or is the product a necessity? If it is a necessity, the product will tend to have inelastic demand. If it is a luxury, the product will tend to have elastic demand. And then again, the time horizon. What is the time horizon a buyer has to react to the price change? If it's a very short-term time horizon, then it's going to be less elastic or even inelastic. If there's a larger time horizon, longer time horizon, then elasticity will be higher. That's it for this part of Chapter 6. When we come back to Chapter 6, Part B, we're going to talk more about how price elasticity of demand affects total revenue, which was the first question you were asked on slide number 2 in your scenario where you're raising the price you charge for developing a website. And what effect does that have on total revenue? We'll address that in Part B. See you there.